In this tutorial, we are going to have a look at how to get data into R and RStudio using an external spreadsheet software. So first of all, we'll have a look at the format of data. R and RStudio use a format known, predominantly uses a format known as tidy data. And this is akin to what's sometimes referred to as long data. And here the row represents an instance of an outcome measure rather than an individual. So rows represent an outcome score and columns code various bits of information about that outcome. For example, from which entity that outcome measure came. Now, this will hopefully make a bit more sense when we actually look at an example. So main thing is each row is an instance of an outcome measure and columns code information about that outcome. So let's look at an example. I'm going to take a Harry Potter related example to do with whether having the power of invisibility would make people more mischievous. So I'm imagining a study here where at some point in the future cloaks of invisibility have been invented, and we've got some participants and we've placed them in an enclosed community, and we've put hidden cameras all around to see what they get up to. Now, our outcome, the measure we're interested in, is how many mischievous acts the participants perform during a week that they spend in this enclosed community. So, we'll code the video recordings and have a little tally for each person as to how much mischief they've got up to. And let's assume here that we can define mischief in some meaningful way. And what we're going to manipulate is whether or not the people in this community have an invisibility cloak. So there's two designs that I want to look at. The first design is what is often referred to as an independent measures design. So this is where we would distribute the invisibility cloaks, or lack of them, across different individuals. So imagine small study, just to keep the data simple. We've got 25 participants and 12 of them we have given an invisibility cloak, and 12 of them have not got an invisibility cloak. So we've randomly assigned invisibility cloaks to half of the participants. And what I'm going to show on the screen, because I can't fit it all on, is a random sample of 7 participants from each of these groups. So this is what the tidy data format would look like. So we've got our main outcome is mischief. So each row of this table represents an instance of the outcome. So it represents a value of mischief, and then the columns code information about that value. So for example, the first row tells us the name of the person attached to that value of mischief. So the value of mischief is 1, tells us who that's attached to, and it tells us in the cloak column whether that person was assigned a cloak or not. Same with row 2. It tells us, first of all, the name of the person from which the score originates, whether they had a cloak or not, and then in the final column, the actual value of the outcome. So the value of the outcome 5 is kind of the primary unit of analysis for the row, and the columns represent information about that. So we know that value of 5 is associated with the no cloak condition, and we know that it derived from an individual called Colin. So that's all there is really to the tidy format. So let's have a look at how we would enter these data. I've got the data already set up in an Excel spreadsheet, and it's slightly different to what's on the slide just because I've got all 24 scores in the Excel spreadsheet. But hopefully you can see I've set it up such that in the first row I've just given name to each variable. So I've given the first column is called ID, which is going to tell us the name of the person from which the data originates. I've got another variable called cloak, which I've called cloak, and in that we're just going to have text that describes whether someone had no cloak or cloak. So if we just imagine you were starting from scratch. I don't want to type in all the names because that's going to be boring for you. So our first participant, we could just type no cloak and just literally type it as text. And in Excel, we can actually just drag that down over all the people in the cloak condition. So first 12 participants. Then we move on to the cloak condition. And again, we can just type that in once and then drag it down over the others. So it's pretty quick. And then we would put there the score for each person, the mischief score, how many mischievous acts they committed in this final column. So that's how you enter the data for an independent design. Pretty much always, I would say, have an ID column. I mean, normally it would be anonymized rather than actually having people's names. But have an ID column that identifies from the source of the outcome measure, and then have variables coding the information about that score. So in this case, whether it's from a no cloak condition or a cloak condition. Now, if you want to output that, then you can just go to the File menu, Save As, and then navigate to the data folder of your project. Give it a name, and crucially, we want to save it as, so by default, if you're in Excel, for example, it will save it as an Excel document. We want to save it as a comma-separated value file format. So, I mean, you can import Excel files into R, but it's much easier. It's more straightforward to just work with comma-separated values. So you'd select to output as comma-separated values, and then just click on Save. Now, if you want to use something like Google Sheets, let's get Google Sheets up. You'd set up a blank document. And again, just kind of do the same thing. So you have your variable names at the top, ID, cloak, mischief, and then we'd start inputting names and I can't remember any of the names, even though I literally just looked at it. And then their scores, the first score was 1. So I'll move on to the next person. And again, for things that are repeating, you can just drag down. And then in Google Sheets, you go to File and then Download. And again, it gives you various formats you can download, and you just choose the comma-separated value one, and that will download into your download folder. And you could then copy it across to the data folder in your project. So that's independent designs, but the Spaniel of statistics is more into repeated measures designs, aren't you? Just say yes, say yes. Say yeah. Yep, he loves repeated measures designs. Now, repeated measures design is different from an independent design in that the same participants or the same entities produce more than one instance of the outcome measure. So in our invisibility cloak example, this would mean that we gave everyone an invisibility cloak. So what this means is across 2 weeks, everyone would have some time with an invisibility cloak and some time without an invisibility cloak. And in an ideal world, you would counterbalance that. So some people had their first week with the invisibility cloak and the second week without it. And for other people, they had the first week without it and the second week with it. So the design's basically the same. We've got scores of mischief that are associated with having an invisibility cloak or not. The difference is those scores come from the same participants, so the same people have taken part in the cloak condition and the no cloak condition. Now, in a tidy data format, we kind of enter this in the same way as before, but the key thing is here is we kind of in the ID variable, we double up on the name. So for every name, for every participant, for every ID, we have a piece of information associated with when they had a cloak and a piece of information associated with when they didn't have a cloak. So our first participant, when they didn't have a cloak, they committed 1 act of mischief, and when they did have a cloak, they committed 3 acts of mischief. And we can see this from the table. So to enter this, for example, into Excel, which is the same principle as before, all that's really changing here is that every ID, every person in the study now has 2 mischief scores, and those mischief scores are distinguished by whether the cloak variable says no cloak or cloak. So here I've got the data already laid out in Excel, and you can see, I mean, it matches the table. So our first participant, they have a score of 1, and the cloak condition is set to no cloak. And then their second score, so their second week, or their week in the community where they had a cloak of invisibility, is a score of 3. So we know these 2 scores both came from this participant, but are distinguished by this cloak variable. So again, we'd set this up. I mean, let's say again we were going to do this in Google Sheets. So 3 columns are the same as before. So in ID, set up our first participant. We know there's going to be 2 scores coming from that person, so we could drag it down. Then we have no cloak for the first score, cloak for the second score, and then we put the 2 scores in, which was 1 and 3. Then our second participant, drag that down, so we could select both of them and copy them down, and it will fill the spaces again. And then his scores will be 5 and 6. And there we go, and so on and so forth. So again, we save this out in Google Docs by going File and Download. Back in Excel, once we had all these data in, we would go to File, Save As, make sure we've got comma separated values selected, go to our data folder, and I've called it Invisibility RM, and there you go. Having saved the data, once you're in your project, if you look in the data folder, you can now see we've got those 2 files, Invisibility CSV and Invisibility RM CSV. How do we get them into R? Well, let's open a new Markdown document. We've seen how to do this before. Let's call it Invisibility. Click on OK. As we've seen before, we get a load of default stuff in here, which we can just delete, but leave the setup chunk. And then we're going to save this Markdown file within in our project. We've got this RDocs folder. Let's go in there, and we'll call it Invisibility. So this file is now stored in RDocs. So I normally import data within the setup chunk. So we're going to import the data using a function called read CSV, which is part of the readr package, which is part of tidyverse. So to load that in, we'd have to start off with library tidyverse, just to make sure that's loaded. And then we want to put the data into an object. So we need to give that a name. It can be anything you like. Let's call it invistib. And put an assignment operator. Now to read the data into that object, we would type readr, which is the name of the package we're going to use, 2 colons, and then the function within that package is read CSV. You can see RStudio is trying to guess already what we're going to use, so we can just hit return. Now within those brackets, we need to put the location of the file we're trying to open in straight quotes. So let's put the quotes and then think about how we get to the data file. So this Markdown document is in RDocs. So we need to go up a level out of RDocs into the project folder. And to go out of the RDocs folder, we use 2 dots. So put 2 dots in there, then a slash. And then if we type data That will take us into the data folder, another slash. And then we want the name of the file. So within the data folder, we've got invisibility.csv, invisibility.csv. And that's it. If we execute this, we should hopefully import the data into invistib. So there you go. Looks like nothing's happened, but that's because to view this file, we need to execute its name. So if we now execute that chunk again, we can see the contents of invistib is now the same as our CSV file. Now, if you don't like the whole double dot thing, there is an alternative, which is to use the here package. So we have to type library here to access that. Then we delete all of that and type here, because we're going to use the here package. And then within that, we use the here function. And then we're going to pipe that into the readr command. And then within here, rather than using the double dots, you would just type data, because the here package is going to take us to the main folder. So you just type data and then invisibility.csv. It's just doing the same thing as before, it's just in a slightly different way and maybe a way that you prefer. So again, if we highlight and execute that code, it's read the data in. To check that it has, we can execute the name of the object, and again, there's the data. So now we can access an object called invistib that contains the data from our CSV file. So that is how you get data into R from an external spreadsheet. Okay, bye for now.